All right.
Lenny.
So, all right, this is for Lenny. So, first off, we got to write the Keq expression. This one's pretty easy. So, the equilibrium constant expression. So, we should have all gotten Cl2 concentration over times PCl3 concentration all over PCl5 concentration. Okay? So, what we get here, actually, we probably should have done the partial pressures, but when you're talking about concentration of a gas, you're talking about the pressure. So this is our K expression up here. So what conditions do we have here? Let's just calculate this out. So my molarity of Cl2, or my concentration of Cl2 is 1 atmosphere of pressure. My concentration of PCl3 is also 1 atmosphere. And we divide by my concentration of PCl5 up here, which is 1 atmosphere. And we all know, what happens, Brian? The ones cancel out, right? Yes. That's funny.
Why?
It's a joke. It's a joke, guys. Welcome to my world. So let's figure out what's happening here. So let's compare this to my Kp up here. So is my, listen up, guys. Let's compare this to my Kp. Are my conditions, let's call this Q for our conditions. Are my conditions too small or too big? Too small. So Q is less than Keq. So my conditions are too small, which means that this is too big. And up here is too small. So my numerator's not big enough. My denominator is too big. So what reaction am I going to be favoring? So let's think about that for a second. I'm going to favor the forward reaction. Why, Jeremy?
Because there's more dioxide, so it wants to go to the
Exactly. Can you repeat that one more time?
It wants to balance out, and since the PCl5 is too big, then it wants to go to the other side where it's too small and balanced.
Exactly. Great answer.
Okay, I don't get it.
So I don't have enough Cl2 and PCl3. I don't have enough products, and I have too much reactants. So to get to equilibrium, like Le Chatelier's principle, we talked about systems at equilibrium, and then what happens when you change those systems. Here we're talking about figuring out if a system is at equilibrium. Okay? So that's what we're going to do, and it's pretty easy. We'll do a couple examples of this. I have a nice sort of Podolly activity for us. I know. Let's. You guys probably want to take this down. So just I'll pause it for a second. One. Hi, Lenny.
Hi, Lenny.
All right.
Lenny, how are you?
That wasn't me. Rice diagram. You guys want to copy this down? We all like rice. It's the easiest.
The order of the rices?
Yes, it does. Because you'll see. Rice diagram, they're just. It's. So let's move on. So let's go over how to do a rice diagram. So I am recording. Right now.
Is that right, Liv?
So let's first off, we have a balanced equation up here. And let's go over how to use a rice diagram. So first off, R, I, C, E. So we have reaction, initial, change, equilibrium. So let's write out the reaction. CO2 gas plus 2Cl2 gas in equilibrium, or reversible reaction with O2 gas plus CCl4 gas. So what I'm starting with is I'm starting with only CO2 and Cl2. And I've given those initial concentrations. So my initial CO2 is 1.2 molar. I'm just going to write 1.2. You guys can put the units in if you want. I'm not going to do that now. I know it sounds crazy. My initial Cl2 is 2.0. Okay? So that's all I'm starting with. If I'm starting with only these two, that's saying I'm not starting with any O2 or CCl4. So I have 0 both of those. So if I'm starting with only my reactants, what reaction is going to be favored? Forward reaction is going to be favored. So since I only have this, I'm favoring my forward reaction. Okay? Since I have only reactants, only these guys, I underlined it twice. So what's going to happen to my concentration of CO2? Is it going to increase or decrease? Decrease. Same with Cl2. What's going to happen to my concentration of O2? Increase, and CCl4 also is going to increase. So let's say this increases by a number. Let's say, I don't know, let's just pick a random letter. Let's call it X. Decreases by X. So I look to the coefficients, and I know this is a 1 coefficient. This is a 2 coefficient. These are also 1 coefficients. So if I'm going to decrease this by X, what's this going to decrease by? What's the Cl2 going to decrease by? Minus 2X. This is going to increase by X and X. So at equilibrium, I can figure out what my concentration is in terms of X. If I start with 1.2 and I have less X, what am I going to have at equilibrium? 1.2 minus X. And again, if I start with 2, I subtract 2X, I get 2 minus 2X. I start with 0, I add X. Hopefully I get X. And same thing here, I get X. Okay? So what I can get here is there's more information given here. So the equilibrium concentration of CO2 is 0.8. Okay? So I'm going to let you guys for a second see what you guys can figure out the equilibrium constant, okay? So this key information, Brian, at equilibrium, my concentration of CO2 is 0.8. So I can actually tell that 1.2 minus X is equal to 0.8. So what's X equal to? X is equal to 0.4. So what is, I can, you know, let me just put some lines in here to separate things. So what's 2 minus 2X? So 2, is 1.2 at equilibrium and 0.4, 0.4. So now,
how is 1.2 minus X 0.8?
Because I started with 1.2. My initial CO2 concentration is 1.2. I have subtracted X. And I know that my equilibrium concentration of CO2 is 0.8. So I started with 1.2. I ended with 0.8. What's my change? Has to be 0.4. Decreased by 0.4. So then, since I know X, I know I started with 2. For every one of the CO2s, I've reacted 2 Cl2s. That's stoichiometry right there. So I can calculate that as 1.2. So now I can easily go calculate my KEQ. Let's do that in a different color. Let's say we do light blue. So what's my KEQ? Oh, that's terrible. Sorry. Color. Let's go with super dark blue. There we go. KEQ. So what's my KEQ expression, Kalana?
It would be 0.4
Yep.
times 0.4.
Well, let me write down the equation first.
Like which number?
Yep. O2
Oh.
times CCl4 all over. Go on.
Over CO2, Cl2.
Close. Cl2
Squared.
squared. Good. So all I have to do is substitute here, and I get my O2 0.4
I got 0.138.
times 0.4 all over 0.8 times 1.2 squared. And I didn't calculate this yet, but when you guys calculate it really quick, anyone get this one?
I got 0.138.
0.138, that sounds right. So that's my KEQ right there. Because I get that from my equilibrium values. Because this here, these are my at equilibrium. Okay? So I'll post this too, guys. So you guys can have access to it as well. So let's move on. I'll give you guys a second to copy this down.